Okay, this is our first video from Chapter 1. Actually, I introduced Chapter 1 at school today with just some basic reviews of the concept of functions. So this is going to be something from the end of Chapter 1, Section 1, called the difference quotient. And this is an idea that most of you have not experienced or have not done very much of. This is a basic definition from calculus, the difference quotient, and I want you to look right here. I use the words DQ. Difference quotient is defined as f of x plus h minus f of x divided by h. Now I want to just point out that the title difference quotient, this is the difference. You see these two are subtracted, and then the whole thing is divided by this h, and so that's the quotient part. So it's a difference of functions, and then there is a quotient involved. Now, before we actually find a difference quotient, let me review. I'm going to put another sheet on here and just go back and review this whole idea of the value of different functions. Let's say you have a function f of x is equal to 5x minus 4. Okay, that function, a linear function, does not have a specific value right now because we don't know what x is. But I could have said f of 2, and then you would say that's 5 times 2 minus 4, final value 10 minus 4, which is 6. Or we could say f of k, just go along with me here, so that would say 5k minus 4, and we can't do anything with that. We're just letting k be put in for the variable, letting 2 be put into the variable. If I said f of 4p, then you would say 5 times, and the variable will be replaced by 4p minus 4, which just would be 20p minus 4, and that's in lowest terms. And finally, if you wanted to say f of n plus 3, you would say 5 times n plus 3 minus 4. In other words, this goes in for the variable. And so then we would simplify that, 5n plus 5 times 3, 15, minus 4. And you can simplify a little bit here, 5n plus 11. Okay, so this is the idea of a function has no specific value until you give it one. And so in each of these problems here, we've given it a specific value, and we've evaluated. Evaluate means find the value. Okay, now let's go back. I'm going to take this off. Let's go back to our idea of the difference quotient. The definition of a difference quotient is f of x plus h. So in other words, you're going to put x plus h into this particular function. Then you're going to subtract the function itself and divide by h. So let's find, here is our first example. Push this up just a little bit. We're going to find the difference quotient of the function f of x equals 3x minus 1. Alright, so here's our definition. F of x plus h, and this is the same for every difference quotient, minus f of x divided by h. Okay, that's our definition. So now let's apply that to this particular function. So we're going to say, instead of 3x, we're going to say 3 times x minus h, x plus h minus 1. We've let x plus h go in for the variable in this function. Minus, and then I'm going to put a parentheses, 3x minus 1. This is the original function. I'm just going to write original right here. And this is the function with the h put into it. And all of that divided by h. And then we just evaluate. So that comes down to 3x plus 3h minus 1 minus 3x minus 1 plus 1 over h. Now you simplify. Let me move this a little bit. Okay. Simplify 3x minus 3x. I'm going to use my red here to show you that those go out. Disappear, disappear. Negative 1 plus 1, disappear, disappear. And all you're left with is 3h over h. And out go the h's, and your final answer is 3. So the difference quotient of this function, 3x minus 1, is 3. Now, we've got a little time, so we're going to look at several examples, and then I'm going to try to explain to you exactly what the difference quotient is or does. Here is a second example. Let's find the difference quotient of, and let's take another linear function. How about negative 5x plus 3? F of x equals. So this is our function. F of x equals negative 5x plus 3. So the definition is, again, the dq is f of x plus h minus f of x divided by h. That's our definition. In fact, let me just kind of put this in a little cloud so you can remember it. That's the definition of the dq, the difference quotient. Okay, so here, let's go here. F of x plus h says take this function, negative 5, and instead of x, put in x plus h plus 3, and then minus, now put some parentheses, and copy the original function, negative 5x plus 3, and put the whole thing over h. See, this is the difference up here, and this is the quotient right here. Now let's simplify that. Negative 5x minus 5h plus 3 minus 5x is plus 5x minus 3 divided by h. Let's clean up the top of that. Negative 5x, positive 5x, positive 3 minus 3, and what you see left is a negative 5x negative 5h divided by h. Out go the h's, and the answer is negative 5. Now, in case you're wondering if you've discovered some kind of pattern, let me dispel that thought right now. We're going to do a third example of the difference quotient. This one is going to be not a linear, but your instructions would be to find the difference quotient, the dq, of the function f of x is equal to x squared plus 3x plus 2, a quadratic function. Alright, so remember your definition. Look back at your notes if you need to. I need f of x plus h minus f of x divided by h. Alright, so here, instead of this original function, everywhere there's an x, we're going to plug in an x plus h. So here we go. X plus h squared plus 3x plus h plus 2. Now you see that's the function f of x plus h. That's an x plus h here, and then just the 2. Then minus, here are parentheses so we can keep our signs right, x squared plus 3x plus 2, and all of that over h. Okay, now let's clean that up. First of all, let's square x plus h. So we're going to have x squared plus 2xh plus h squared. That's squaring, square the first, double the product, square the last. Plus 3x plus 3h plus 2 minus x squared minus 3x minus 2 all over h. Now you can pause this at any time if you need to look back and figure out where these parts came from. Let's clean up. Here's an x squared and here's a negative x squared. Here's a positive 3x, here's a negative 3x. Here's a positive 2, here's a negative 2. I'm left with, it looks like, 3 parts. A 2xh plus an h squared plus a 3h and all that's divided by h. Now you know how this works. You can only divide if you can divide it out of all the parts, but you can here. Let's take an h out of the top, and you'll have a 2x plus an h plus a 3 divided by an h. This h takes out this h, and the answer to your difference quotient is 2x plus h plus 3. That's your answer. Okay, now, after all this is done and we've practiced finding the difference quotients, you might be interested in what is a difference quotient. What is this talking about? And in calculus, we do a lot of talk about slope, because slope represents what we call a rate of change. Now, let me just show you a little bit on a parabola. Suppose you just have a parabola, and you can pick a point on that parabola. Let's pick this point right here. If I drew a tangent line, tangent meaning just touches that in one point, you see that tangent line is fairly steep. It has a fairly steep negative slope. If I came to another point on the curve and I drew the tangent line there, it is still negative, but not nearly as steep as the one before. If I were to catch this curve right at the vertex and I were to draw the tangent line there, you can see its slope would be 0. It's not changing at all at that split second. But then I could continue around the curve, and you can see the tangent lines get steeper and steeper. And so what this is basically saying is, as you look at this curve, the point that you choose to evaluate, the slope is changing. So if I pick this point, the slope is negative. If I pick this point over here, the slope is positive. If I pick this point, the slope is still negative, but much less steep than this one here. And the slope of the tangent line, is a very important idea in calculus, because it measures, it talks about the rate of change, how fast something is changing based on the slope at this particular point. Now, the difference quotient is used to find something called the derivative, and the derivative measures the rate of change. So the difference quotient is an important idea in calculus used to find the derivative. Now I've just got a few seconds left, so let me see if I can bring this all home. So, you know, the first two examples that we did were examples of lines. We did the dq of f of x equals 3x minus 1. Now you know that's a line. Y equals mx plus b. And the value of the dq was 3. The second example we did was f of x is equal to negative 5x plus 3. And it just so happened the difference quotient was negative 5. The third example we did was a quadratic x squared plus 3x plus 2, and the difference quotient turned out to be 2x plus h plus 3. Now what you'll learn to do in calculus is when you have an h left in the derivative, you'll let that go to 0. So you'll end up with 2x plus 3. Now what you can do with these is you can use the x value of your curve at that point and put in your x here and actually get the value of the derivative. The reason these two are the slopes is because the slope of the tangent line, in this case the line is itself is the only line there is, and so its slope measures the derivative. I'm going to have to close now because I'm running out of time, but we will work on difference quotients today in class. Thanks for listening.